Hello, today we will be doing the properties of salts under the chapter acid, bases and salts. We had already done definition and classification of salts, so we will be doing only properties in this video. Salts are electrovalent compounds. They conduct electricity in the molten state as well as in aqueous solutions. In aqueous solutions, they dissociate into ions. These are non-volatile solids and form crystals. Mostly the salts are soluble in water and their solubility varies with temperature. There are three types of salt you can say depending on the solubility. 1 gram of substance soluble in 100 ml or 100 gram of water at 298 Kelvin is soluble salt. 0.1 gram to 1 gram which can be dissolved in 100 ml or 100 gram water at 298 Kelvin is partially soluble. If less than 0.1 gram of substance is dissolved, then it is insoluble salt. This is the solubility chart where solubility is shown in grams solute per 100 gram of water at different temperature range. You have to remember only the temperature range. Now you know that the salts are formed by the neutralization reaction between acids and base or alkali. So their solutions are expected to be neutral, that is pH should be 7. But these nature of the salts are generally dependent on the nature of the acid and the base from which it is obtained. Now here there are salts from different acids, types of acids and bases like strong acid, strong base, weak acid, weak base, strong acid, weak base, weak acid, strong base. Now from this ions or the portions like sodium, sulfate, you can identify the acid and the base. Sodium generally comes from the sodium, ammonium, okay. The potassium, calcium, these are generally contributed by the bases. Sulfate, chloride, nitrate, carbonate, acetate, these are generally contributed by the acid part. And here you can see the acid is strong, so the pH will be acidic. Here you can see the base is strong, so the pH will be basic. But for strong acid and strong base as well as weak acid and weak base, generally we get the neutral salt. So how do you find out the pH of the salt? What you have to do? You have to prepare a solution of the salt and then check the pH with the pH paper or the universal indicator. These are the list of certain salts which are soluble as well as insoluble in water. This you cannot learn in a day or two. You have to practice this with the help of different questions and problems so that it will be remembered by you very easily. Now hydrolysis of a salt. This is the phenomena due to which salt formed by weak acid and strong base or strong acid and weak base reacts with water to give an acidic or an alkaline solution, which is known as hydrolysis. Now if the salts formed by strong bases and weak acids hydrolyze in water to give the alkaline solution. Who is strong here? Base. So you will get the alkaline solution. Examples are given. So you can see this is the weak acid, strong base, weak acid, strong base. So you will get the pH of the solution as greater than 7. That is basic. Strong acid and weak base salts hydrolyze in water to give an acidic solution pH less than 7. You can identify who is the strong acid and weak bases. You can see we are getting the strong acids. Salts derived from strong acid, strong base, you will get the pH is equal to 7. Salts formed from weak bases like weak acids and weak bases may be acidic, alkaline or neutral depending on the dissociated ions and undissociated molecules like ammonium acetate. Ammonium hydroxide is the weak base. Acetic acid is also the weak acid. Ammonium hydroxide is the weak base. Carbonic acid is also the weak acid. So from this you have to check the dissociated ions and undissociated molecules. On this basis it will be giving the acidic, alkaline or neutral solution. Now water of crystallization. This is known to you, but still I'll just make a brief. This is the fixed amount of water molecules that are associated with crystals as an integral part of their constitution. Water of crystallization is in loose chemical combination with the salts, and generally those salts are called hydrated salts. You can see the example of dehydration of copper sulfate, which is copper 2 sulfate, means the valency of copper is 2. This is CuSO4.5H2O. This is blue in color. If you heat it, you will get the white, that is anhydrous copper sulfate, and you will get here 5H2O. And if you add again water, you will get the blue color. Generally, one copper sulfate molecule can associate 5 molecules of water. So salts lose their shape and color, as well as water of crystallization is lost at about 100 degrees Celsius, and this copper sulfate is called anhydrous copper sulfate. Now whatever water you are getting, here you are getting some water of condensation. So this is called water of condensation. Once you heat this blue color, you see here you are getting the white color, and this is the blue remained, and this is the water of condensation. So how do you test? We will see that it is neutral to litmus paper. If you put a few drops of liquid to the white anhydrous copper sulfate, a blue patch will be formed, showing that the liquid is water. Also, this liquid turns blue cobalt chloride paper pale pink. So that also gives you the indication that the liquid is water. These are certain hydrated salts. You have to learn this and their common name. You have to learn the hydrated salt formula as well as their common name. But all crystalline solids do not contain water of crystallization. Now there is another term, decrypitation. Now if you have salts like sodium chloride, KNO3, this is sugar, C12H22O11, this is potassium permanganate, ammonium chloride, they do not contain water, but still they are salts. NaCl produces crackling sound. This is called decrypitation, which means the bigger crystals break into the smaller one. And if you heat potassium nitrate as well as sodium nitrate also, they melt on heating into a colorless liquid. They produce oxygen on further heating. So you will get the white color potassium nitrate and sodium nitrate gives you yellow color potassium nitrate as well as sodium nitrite respectively, and oxygen gas. They do not produce any water. Now the term efflorescence. Efflorescence is the property of substances to lose wholly or partly their water of crystallization when their crystals are exposed to dry air for a short period of time even. Now this is very important, exposed to dry air. The substances become powdery. Such substances are called efflorescence. So they will lose the crystalline structure. There will be the loss of weight because water will go away. Here copper sulfate.5H2O is also an example. I have given some other 3 examples, but copper sulfate.5H2O is also an example. Crystalline salts crumbles into an amorphous powder. If you have the temperature higher and less moisture in the air, higher will be the loss of water or efflorescence. Now there is another property, deliquescence. This is the phenomena in which a water soluble substance on exposure to atmosphere at ordinary temperature absorbs moisture from the atmosphere, becomes moist, finally dissolves in the absorbed moisture to form a saturated solution is called deliquescence. And the substances are called deliquescent. Examples are potassium hydroxide, sodium hydroxide, magnesium chloride, zinc chloride, FeCl3 that is ferric chloride, calcium chloride, zinc nitrate, copper nitrate. This occurs when vapor pressure of the salt is less than the atmospheric vapor pressure. These can be minimized during dry condition. Now you remember, efflorescence can be increased in dry condition. but deliquescence is minimized during dry condition, where efflorescence is maximized. This is the basic difference between efflorescence and deliquescence. Now come to the hygroscopic substance. These substances absorb moisture from the atmosphere, but they do not dissolve in the absorbed moisture. Like concentrated sulfuric acid, P2O5, that is phosphorus pentoxide, calcium oxide, silica gel, etc. These are used to remove moisture from the gases in the laboratory. Differences between deliquescent hygroscopic substances are given over there. One, absorb water and dissolve in it, and these absorb water but do not change state. This is the differences between drying agent and dehydrating agent. This is same like you have studied in your class 9 water chapter. This also you know, table salt turns moist and ultimately forms a solution on exposure to air, especially during the rainy season. But pure sodium chloride is not deliquescent because the commercial version contains generally calcium chloride and magnesium chloride as impurities, which are deliquescent substance. This kind of impurity is removed by passing a current of dry hydrogen chloride gas through a saturated solution of the affected salt. Pure sodium chloride is produced as a precipitate that will be recovered by filtering and washing first with a little water and finally with alcohol. This you have to remember. Now, decomposition of salts by acids. This is the effect of dilute acid on different salts. Now, acids of different strength. This is the effect of dilute acid. This is the effect of concentrated acid. Acids of different strengths decompose salts differently. Dilute acids liberate gases. You see here, FeS, H2SO4 gives you H2S as a gas. Calcium carbonate gives carbon dioxide. All carbonates give carbon dioxide. Sulfite, sodium sulfite, SULPHITE gives you sulfur dioxide. Now, concentrated acids, their less volatile acid gives you more volatile acids. When concentrated acid, less volatile sulfuric acid reacts with potassium nitrate, gives you nitric acid, which is more volatile. Here with NaCl it gives more volatile HCl, that is hydrochloric acid. So this is the end of the properties. Thank you.